Hi, my name is Stacy Thibodeau, and I teach chemistry over in Louisiana from my classroom. I'm sending this to you. And I teach at Southside High School. I teach both honors and dual enrollment chemistry. And I just wanted to kind of share with you a little bit what I do in my classroom. And I love using TI technology with the simulations. So the screen here, I have my email contact information if you're a Twitter person and you want somebody to follow you, maybe to share ideas with. Also, the QR code is the link to the presentation if you want it. There's hyperlinks within the document for all the different activities. And so you're probably like, Stacy, why would you use simulations in your classroom when you're a lab teacher? You can teach labs. Well, sometimes things change. And right now we are in a changing environment in education. And so it may be that we can't do the same labs we've used year after year, no wet labs or very few. And so simulations allow for us to have a contact-less classroom. Maybe you can still do the same labs, but we want to have some pre-instruction, some information that is front-loaded for the students for us to lead into the labs. Maybe it's students didn't understand what was done in the classroom. Simulations can show different views and molecular levels of what's being done in the classroom. Maybe students were absent and they weren't able to accomplish what was in the classroom. You could assign them a simulation, or maybe it's just a time saver. We know sometimes curriculum can get overwhelming. There are things that can happen where we can't get to what we wanted to get to, or we can't cover because of time constraints. We can get a simulation done in a lot less time than maybe what we'd have done in a wet lab. And so right now, depending on what software platforms you use, there are some simulations both for the TI-84 as well as the Nspire. The Nspire app on the iPad, also simulations can run on it. Or maybe you're in a virtual setting right now and you need a teacher software. There's a teacher software for the Nspire as well as the 84 Smart View for the 84 users, where you can have one computer classroom where you're projecting and then having and leading classroom discussions. So one of my favorite activities is this activity. It's called Build an Atom. And I find that students come into chemistry with some knowledge about the structure of an atom, but they really don't understand where and what is really happening on the individual levels. So let's go to the TI-Nspire CX Premium software. This is the Build an Atom activity. And with it, I'll show you where I got it. There are different pages set up, and each page has something different. And there's always instructions. And you could do this whole computer, one computer, whole class discussion. Maybe you want to show them how one works, and then you turn them loose on their individual handhelds. Depends on you. I use this as an explore activity where it helps to pull in information that the students might have had from prior classes, help clear up misconceptions, and it also allows me time, because it's usually in the beginning of the year, to walk around and get to know students a little bit more. So this is what it looks like. We have a little scale here, we have a square here, and we'll figure out what that square does. We have protons, and they match to the red dot. We have neutrons, they match to the gray dot, and then we have electrons that match to the blue dot. And so I just tell students, start adding them. When I add a proton, where did it go? Well, it went in the middle, Miss Tibb. Yep, what's the middle called? It's called the nucleus. Awesome. Protons go in the nucleus of an atom. We write that note down. Now I have the name of an atom. It's called hydrogen. So protons, we get a name for it. I got a symbol. I got some number in black up here, which does not correspond to anything in the terms proton, neutron, or electron. So we'll see what that is. This number 1 at the bottom, I bet you that's going to tell me the number of protons because it's red. But then I have this +1, and I have this little meter over here, and this +1, it's on the red side. That means it's a +1 ion. This must be a charged plus positive particle. So we write that down. The last thing is this little scale right here. I have 1 proton, and that is it, and my mass increased. That's what that number is. So then protons add to the mass of an atom. Let's go. Let's add a neutron. I add a neutron now. This neutron went to the center. It increased the mass. I see it, mass is increased at the top left as well as on the scale, but it did not affect the charge. Nothing happened. So neutrons are neutral. So we write all that down too. I go add an electron. Now an electron did not go in the center of the atom. So I'm gonna write that down. It also changed my charge. I went from a +1 ion to something neutral now. So a plus and a negative, positive and a negative. So negative would be an electron. The number down here never changed. I never changed the name of my atom. I didn't affect the mass. So here's one atom. So then I would have students go play, add some more protons, add some electrons, and they can add some neutrons. And then neutrons do something really cool. They actually become an atom. If you add too many, they become unstable. And so unstable to a student means something's probably going to blow up. Well, it could. And now we can start having a conversation about radioactive decay. And what does it mean for an atom to have a certain number of neutrons and a mass that is different? You can talk about relative abundance and isotopes and all that. So I would have the students walk through a couple of them, call time, make sure everybody had all their notes. What do we want to discuss? And then there's a fun little game. So this game can be timed if you want. You want to see how many smiley faces they get. So this problem says I have 5 protons. Well, I remember protons was down here. And I remember that protons plus neutrons was my mass. So I'm going to go change that. Oh, it must be B, whatever the element B is. Then they can go look. Oh, that must be boron. And it needs to have 5 electrons. Let me go check. Oh, got it wrong. What was it? So there should be no charge up here. So you're having the students model what you would have them maybe do on a quiz or a test so that they can advance their chemistry knowledge. So build an atom is really fun. Another one of the simulations that I really enjoy is balancing chemical equations. Again, students have a hard time understanding the symbolic version or view of chemistry and the molecular version. So if you can do things to link those together, the better the students will understand. So this balancing chemical equations activity does that. So balancing equations. So I did download this from the TI-Nspire website, and I will show you in a minute. So this one walks us through what is happening in boxes. And so I have a box of reactants and I have a box of products. And so I'm on equation 1, level 1, so they should be fairly easy. I know that I have to put some of them in there. So if I click on the 1, it puts 1 carbon in both product and reactant. I put 1 sulfur on both product and reactant. And I have to have 1 CS. Well, knowing a little bit about law of conservation of matter, law of conservation of mass, I have to have equal number on both. I see on this side I have 1 carbon and 2 sulfurs. And so if I go put a 2, now a student can see 1 carbon by itself, 2 sulfurs by themselves, but when they come together in a chemical reaction, they make a molecule of CS2. And then I get a green check mark that tells me I did it right. Click to the next equation. 1 of each. Let's see what happens there. Oh, it just so happens it balances with 1 of each. Go to the next one. 1 of each. Well, I have some excess of the chlorine, so I need to make another KCl. But now I have 2 Ks. Let me go put a KO. Oh, that worked. So just having them see not only the numbers and the symbols, but then also on the molecular level view what those symbols represent. And then there's some questions. So if you need some formative assessment probes, you need some questions to gather the information from the activity to see if they learned it, the questions are already there for you. You can send them out to the whole class using the TI-Nspire Navigator Network, or you could put it in a Google form. You could have them discuss it whole class and you come up with a class consensus, however you want to do it. But it allows you to have measurable outcomes from this simulation that you did. Another one for me, simulation, an area that students often find and struggle with is acids and bases. It is a huge foundation for advanced biology and advanced chemistry classes. And if a student doesn't understand what's happening on the molecular level, then we're in trouble. So the first one that we're going to do is called swimming with acids and bases. So swimming with acids and bases looks at putting acids in water and bases in water and what happens when they dissociate or break up. And so there's some information that tells you what to do. And so I have hydrogen chloride gas, and it's a gas. It tells me that, but it's also a gas because these are particles moving around. You can have a discussion. How do you know it's a gas? Well, they're hitting each other. They're hitting the side of the wall. They're rotating around. Those are all properties of gases. What if I increase the temperature? What would happen? And what if I decrease the temperature? Then if I go add some water to it, what happened? Well, it's not hydrogen chloride gas anymore. That gas broke up and it is now a hydrogen ion and a chloride ion. And we would call that dissociation. And some questions to come around. Let's look at hydrogen fluoride. So it looks the same as hydrogen chloride. It's bouncing off the sides of the container. It's bouncing off of each other. It's rotating. Let's add some water to it. Oh, well, this one, not all of the hydrogen fluorides break up. So this is where we see not all of the material dissociates. And so we would consider this a weaker acid than the hydrogen chloride. You could actually calculate percent dissociation based on the molecules and then lead that discussion into further information. Now let's try a base. So here's some sodium hydroxide. We see it all nice, cute little lattice solid network, and they're not floating around. Oh, I have some pieces breaking off. And it shows that it breaks off into a sodium ion and an OH ion. And as those particles dissociate, they go and break up others. And so we can see that this actually completely dissociates. We could calculate percent dissociation. More questions. And the last one, which I really like, is ammonia gas. And this ammonia gas, when we put it in water, doesn't behave the same way at all. I end up with an NH4 ion and an OH minus ion. And so to have students only look at acids and bases in the symbolic view, now we can see that they can actually see what is happening on the molecular level view and hopefully understand a little bit more. One more is called molecular titration. And so with titration, I know a lot of teachers don't have a lot of time for titration. Maybe they don't have the materials for titration. But this simulation allows for you to have the experience with titrations and also look at the graphical analysis, which they may see a type of graph like that on a standardized ACT or SAT test, and also a molecular level view. So it's a titration with hydrochloric acid and sodium hydroxide. And so some questions, like I mentioned, there's always questions, which are great. You can leave in or take out. And so we're going to start with a beaker of hydrochloric acid, and in the burette is sodium hydroxide. It tells us that there will be a color change when the pH changes. So what we have over here on the right is the molecular level view. At the top is our graph of what's happening. We have our pH meter, we have a stir plate, and our beaker and our burette. So I'm going to go ahead and turn everything on, and you can pause it with the students. What do you see happening on the molecular level view? Well, there's just hydrogen and chloride ions. If you go back to swimming with acids and bases, we know that that's what happens when we put hydrogen chloride in water. If I slowly start adding some sodium hydroxide, I end up with some water and I end up with a sodium ion. So what is happening is we're starting to have some neutralization of that acid and base. And my graph is starting to change. I'm starting to get a noticeable difference in the pH. My pH is changing. I have some more of my water forming and more sodium ions floating around. And as I continue to do this, we all know with titrations, there's just that one point right before you put one more drop. And now it's pink, which tells me the pH that indicator notices. And notice all of my hydrogen ions are gone. They have been neutralized. I have a bunch of new blue ions, but I have all my chloride ions because they're not truly part of this reaction. You can talk about spectator ions. If I keep adding, notice my sodium numbers increase, and now I'm starting to get some OH minus molecules. And so another conversation of where does the shift in equilibrium happen with this type of simulation? And then there's more questions. So just a great way to show molecular level views, but at the same time, availability of the graphs and then as well as the symbolic. There is a zombie apocalypse activity. So there's actually two. Zombie apocalypse 1 looks at the zombie virus and how it affects the brain. Zombie apocalypse 2, we now know that the zombie virus is a prion virus, and we can titrate the blood to kill it. So it's just another titration lab, just fun. I always do it on Halloween Day. I do a lot of different things on Halloween, but I always do Zombie Apocalypse 2 with my students just for something fun. All right, so more information. Where did I find all these? Well, first is the TI-Nspire science-inspired website. So I'm going to go to it. So if you go to the main Texas Instruments website, education.ti.com, under activities and Science Inspired, that is where I found all of these activities. I found the one for chemistry and atomic structure and periodic table. When I first started teaching and first started using TI technology, I would come to the website, see what they had, and then build my lessons around it. So this is where I got Build an Atom. If you click on Build an Atom, brings you to a objectives page. Maybe you have to write objectives or show objectives on your lesson plans. Some key vocabulary. And then over here on the right are all the downloads. You can download a notes page for the teacher. I would definitely do that the first couple of times you did these activities, just to help you be familiar with where the activity is going, what are the main concepts trying to cover, and also there's some tech tips. There's 2 student activity docs. One is a doc file, one is a PDF. Maybe you want to add your own information. You can do that with the doc file. And then the last one is the TNS file, which is what you saw me show on the Teacher Premium software. Here's where the 84 activities are. They are on the 84 activity central, and I went under science. And so you can click on whatever the standard is, and then there are different activities for it. And maybe you don't have the technology yet for the students to have in their hands, but you wanted to do what I did with whole class. There is a 90-day free trial of the premium software. So that link brings you straight to the page that you can actually apply for the software. Definitely worth it. So I hope you guys enjoyed this little presentation with teaching science through simulations. Please reach out if you need anything, if you want to bounce ideas off of someone, maybe how I tie in different chemistry concepts, especially in my Chemistry 2 class. I'll be more than happy to help. Thank you.